day of lesson, guys. Square root functions. Start with this one. So the square root function is basically what it says. It's a function where you're taking the square root of a number. So square root of 0, 0. Square root of 1 is 1. Square root of 2 is 1.4. Square root of 3 is 1.7. Square root of 4 is 2. And if you turn these into coordinates, you have points that are slowly curving upwards. And now it's still going up. But if you notice, it doesn't go anywhere in the negative direction. Like there's no points down here, and there's no points on the negative x, because if you remember, we are not supposed to take square roots of negatives. Okay, now that doesn't mean you can't have a negative in the problem, but the last thing you do shouldn't be taking the square root of a negative. So the parent function doesn't have any negative numbers. All right, now let's talk about how it can be changed, how this could be moved. So what if I add something to the function like this? Okay, if I add something to the function, like a plus 5, all the inputs, all the numbers you plug in, are you're gonna take the square root, and then you're gonna add 5 to all these numbers. What happens is this. That entire curve for the square root function went up 5 units. 1, 2, 3, 4, 5. So in the past, we called this k. So this will tell you to move that starting point up. Okay? Now that's on the inside. Sorry, that's on the outside. What if you put a number on the inside? Well, if you put a number on the inside, like right here, minus 5. What happens to all the numbers when you plug it in, before you take the square root, you have to subtract 5. Okay? Now, the problem with that is, if you plug in 1, you get negative 4. And you can't take the square root of negative. If you plug in 2, you get a negative 3. You can't take a negative. The only number you can start with is actually 5. Because if you plug in a 5, 5 minus 5 is 0. So 1, 2, 3, 4, 5. Your starting point isn't here anymore, because all of these numbers would give you a negative inside. But once you get to 5, then your curve goes that way. So what did this do? Instead of moving it up or down, it moved it to the right. Now, in our previous vertex form, this was known as h. So your point moved. Now, if you put those two things together, you get this, where h and k is a coordinate. Okay? And the h and k can move it in different directions. The k moves it up and down. The h moves it left and right. So it's not a vertex, okay? But it is like a starting point, like a minimum or a maximum for this kind of curve. So let's do a couple examples of this. Let's say you want to translate the function, 3 units left, and down 4 units. Okay, so this is the parent function. This is the original. If you're going to move it left 3 units, you go 1, 2, 3, and then 4 units down, 1, 2, 3, 4. Your curve is now here. But it would continue to do what it did before. It would grow. Now, this would be a new equation. If we follow this format, all we do for the function is put in the numbers that we moved it with. So how much did we move it to the left? We moved it over negative 3. Now, if you plug in a negative 3 in here, that goes right there. And then you moved it down 4, negative 4. All right, now your final function would be x plus 3 minus 4. Because you have 2 negative signs inside, that's actually a plus sign now. And guys, this would be the function. This is what it would look like. Because you moved it over negative 3, negative 4. This is your new point. Now this point right here, would this point be called a minimum or a maximum? Well, if this point is the start and then it curves up, this would be a maximum at this coordinate. That would be the maximum. I'm sorry, That is wrong. Forget I said that. It is the lowest point. It keeps getting bigger and bigger and bigger and bigger. That means it's not the maximum, it's the minimum. Jeez. I can't believe I almost gave you guys that information. I apologize. No, this would be the smallest point because it keeps getting bigger from that point forward. So this would be considered the minimum point. Every other point is bigger than this point. Okay, it's moving in the positive direction. Now let's talk about domain and range. Normally, the 0 is where it starts. So like, if you were going to give me what numbers you can plug in for domain, it's all the numbers bigger than 0. But because you moved it, now your domain for x is not numbers bigger than 0, it's numbers that are bigger than or equal to -3. Because now this at -3, that's where it started. What about the range? Well, the range would be for the y value, and it's not at 0, it's now every number greater than or equal to -4. If we were talking about the original one here, if we were talking about the parent function, the answers for this one would say, okay, greater than or equal to 0, greater than or equal to 0 for y as well. That's what the normal one is, because the original starts at 0, 0. This is the minimum of the original function. But once it's moved, you have to work with this point now. And this point now is where you're going to get your domain and range. Okay? Now it is possible to have it go negative. I wasn't going to really spend a lot of time on that. But if you multiply the function, let's say you put a negative number in front. If you put a negative number in front, then it flips upside down and the curve goes down. If you put a negative on the inside, then the curve actually doesn't go this way, the curve actually goes that way. So there are other ways to manipulate it. Play with Desmos and you can see what happens. But we're going to mostly focus on the minimum or the maximum point. The last thing I'm going to ask you about is finding the rate of change, or the average rate of change. Now normally we use slope here. The problem is this function isn't a line. So we're not really finding the slope. But you still need 2 points. So you need an interval. An interval is a set of points that you're examining. Okay? So we're going to examine these 2 points. So what you need to do is plug in 1 and plug in 4 into the function. 4 times 1, 4 times 4. Okay? This gives you square root of 4. This gives you square root of 16. My answer is 2. My answer is 4. So your coordinates, your points that you're dealing with are 1, 2, and 4, 4. Now if you remember the slope formula that we're going to use, slope formula is y2 minus y1, x2 minus x1. So the reason I like to write it as points is because these numbers are my y's and these numbers are my x's. So I'm going to do 4 minus 2 and 4 minus 1, and I get 2 over 3. And this is my average rate of change. My average rate of change over the interval for this is 2/3. And that's it. So you're just using slope formula with the intervals they're asking you for, finding the points, plugging it in. Okay? And that's it, guys.